Hi class, in this lecture I just want to introduce you to problem solving techniques. Basically in this section what we're going to do is we're going to be given word problems asking for some type of information or for us to solve for something, and we're going to talk about steps to solve them, and we'll work a bunch of examples. All right, so we really only have one objective here. We want to solve problems using the organization of the four-step problem solving process. So there's going to be a four-step process here. Okay, so what are the four steps here in problem solving? Okay, so the first thing we want to do is we want to understand the problem. Okay, like we want to read the problem several times. The first reading can serve kind of like as an overview. Then in the second reading, what we want to do is we want to write down what information is given, so what they're telling us, and we want to determine exactly what the problem requires you to find. All right, so reading and writing down what we're given and what we're required to find. And now in step two, what we want to do is we want to devise a plan. Like we want to get a method for solving. So the plan for solving the problem might involve one or more of these problem solving strategies. Okay. So it really just depends on what you determine by reading it. Okay. So the first one is we want to use inductive reasoning to look for a pattern. Okay, like is there some type of pattern within the problem that's going to help us solve it? The next thing is maybe make a systematic list or table, like maybe a table of all the data will help us. We'll do that a little bit in one of the examples. Maybe we want to use estimation to make an educated guess at the solution, then check the guess against the problem's conditions and work backwards to eventually determine the solution. And the next thing we want to try expressing the problem more simply and solve a similar, simpler problem, maybe. All right, we can use trial and error, like kind of like a guess and check to help us solve. These are all valuable ways to solve it. Okay. All right, this is some other ways. We can list the given information in a table or chart. Maybe looking at that will help us glean something. We can try making a sketch or diagram to illustrate the problem. You can relate the problem to similar problems that you have seen before. Okay, like trying to apply the procedures used in similar problems to this new one to help you solve this new one. You want to look for what they call quote unquote a catch. If the answer seems too obvious, perhaps the problems involve some sort of trick question deliberately intended to lead the problem solver in the wrong direction. So, if it's like too easy, maybe just make sure you're not falling for something here. We want to use the given information to eliminate any possibilities for a solution. And then finally, I know it seems silly, but a lot of these problems, you can just use common sense. Throughout your academic career, you've learned quantitative reasoning skills, problem solving skills. Maybe just like apply what you know to solve the problem. Just use the common sense that you have. After you've done that, the next thing you're going to do in step three is carry out the plan and solve the problem. Basically, you're going to solve it mathematically. In step four, you're going to do is you're going to look back and check the answer. Okay, so the answer should satisfy the conditions of the problem, and the answer should make sense and be reasonable. If this is not the case, then recheck the method and any calculations. So perhaps there's an alternative way to arrive at a correct solution. All right, so the answer, once you get it, makes sense and reasonable. Think about that always. All right, here's an example of finding out what is missing. Okay, so suppose you get this thing. It says, hey, a man purchased 5 shirts, each at the same discount price. How much did he pay for them? Well, think about that. All right, so understand the problem. Here's what is given. All we know is the number of shirts purchased. Man purchased 5 shirts. All right, we must find out then how much the man paid for the 5 shirts. That's what they're asking for. How much did he pay for the 5 shirts? Okay, devise a plan. Well, the amount that the man paid for the 5 shirts, okay, is the number of shirts 5 times the cost of each shirt. Like, for example, if the shirts cost, $20, all right, 20 times 5, you spend $100. But the discount price of the shirt is not given. Okay, so like so the missing piece of information here makes it impossible to solve this problem. Like I don't know how much he paid per shirt. Okay, so right there I can just be like, look, this problem isn't going to work out. All right, here's a one that will work out, okay? So by paying $100 cash up front and the balance at $20 a week, how long will it take to pay for a bicycle costing $680? So basically, like it's imagine, all right, look, I want to go buy this bike, costs $680. I only have $100 cash on me. So if I pay that cash, okay, and then I'm going to spend $20 a week paying it off, how long will it take me to pay it off? Okay, so understand the problem. Here's what we're given. Given the cost of the bicycle, $680. The amount paid in cash, given $100. And then I've got these weekly payments. I'm going to pay $20 a week. Okay? Boom, boom, boom. That's the given information right there. All right, I want to devise a plan. All right, well, obviously it makes sense to subtract the amount paid in cash from the cost of the bicycle. Right? This results in the balance. So this balance is the amount still to be paid. Then what I want to do is I want to divide this result by the weekly payments of $20, right? To find out the number of weeks required to pay for the bicycle. I think that makes sense. So let's carry out the plan and let's solve the problem. So let's find the balance. So after I subtract the $100 paid, I still owe $580. Now to figure out how much I have, how long it's going to take me to pay it off, divide this balance, this $580 by the 20 I'm going to spend, okay, to find the number of weeks. So 580 divided by 20, it's going to take me 29 weeks to pay this bike off. Seems like a long time, okay? More than half a year. All right, let's look back and check the answers. So we can double check the arithmetic we just did. We can also see if the answer satisfies the conditions of the problem. So $20 of weekly payment times 29 weeks, that gets me 580. That's how much I'm total on my weekly payments. Plus the amount paid in cash, plus the $100, boom, that does get me to 680, which is the cost of the bicycle. It works out. So the answer of 29 weeks satisfies the condition that the cost of the bike is 680. We got it. All right, let's do an example of making a list. All right, so you're an engineer programming the automatic gate for a 50-cent toll, okay? So you've got a program like basically what this is saying, how much money the gate takes. So the gate accepts exact change only, and it does not accept pennies, okay? So you have to program what it'll accept is what this is saying. So how many coin combinations must you program the gate to connect, the gate to accept? Okay, so like for example, if someone throws in 2 quarters, that works out because that's 50 cents. If somebody throws in 5 dimes, all right, to pay for this gate, 5 dimes is 50 cents. That works out. Are there other ways to do this? All right, so we've got to understand the problem. So the total change must always be 50 cents. So what we need to do, what it's asking, is find all combinations using half dollars, quarters, dimes, or nickels to solve this. You have to program all these in. All right, so what I'm going to do is I'm going to make a list of all the possible coin combinations. All right, so let's begin with the coins of larger value and work backwards towards coins of smaller value. All right, so I'm going to make a list to know that all the possible combinations. All right, let's carry out the plan. So we'll set up the table using half dollars, quarters, dimes, and nickels as the table headings, and then let's count the coin combinations in the table. All right, so half dollars. Well, there's one way I could do half dollars to get 50 cents. Quarters. 2 quarters gets me 50. Can I do it with 1 quarter? Well, yes. I can do it with 1 quarter, 2 dimes, and a nickel. I can do it with 1 quarter, 1 dime, and 3 nickels. I can do it with 1 quarter and 5 nickels. Now at the dimes. Well, I can do it with 5 dimes and 0 nickels, 4 dimes and 2 nickels, 3 dimes and 4 nickels, 2 dimes and 6 nickels, 1 dime and 8 nickels, or I can do it with just 10 nickels. So notice how I started with the half dollars, then moved down to the quarters, decreasing it, then to the dimes, decreasing dimes, and then the nickels, decreasing nickels. So it looks like there I'd have to program in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 2, 4, 6, 8, 10. There's 11 different ways this could happen. So when you look back and check the answer, double check to make sure all the possible combinations that you found, they add up to 50 cents. And it does look like it does. Whenever you do this, it double checks to add up all of them to 50 cents. Okay, let's talk about using a diagram. 4 runners are in a 1-mile race. We got Maria, Athena, Thelma, and Debbie. Points are awarded only to the women finishing first or second, and the first place winner gets more points than the second place winner. Okay, So how many different arrangements of first and second place winners are possible? Okay, so let's understand the problem. Okay, there are three possibilities for first and second position. Okay, so you could have first place. All right, just take Maria, and then there are three people with the second place. Okay, Aretha, Thelma, and Debbie. So the possibilities for the first and second place here. Now these are all with Maria finishing first. So it looks like there are three ways you can have um, possibilities where Maria finishes first and then somebody else finishes second. All right, note that Maria finishing first and Aretha finishing second is a different outcome than from Aretha finishing first and Maria finishing second, since first place gets more points than second. So we need to figure out all the rest of the combinations. All right, so listing each woman as the first place winner and pairing her with each of the three other women results in what we call a tree diagram. All right, so the final column shows all the possibilities. So Maria with everyone else finishing second are all those problems. Aretha finishing first, and then we could have Maria finishing second instead of first. Thelma and then Debbie. These are all those possible. Thelma then Maria. Thelma then Aretha, and then Thelma then Debbie. You can see the outcomes listed. Debbie then Maria. Debbie then Aretha. Debbie then Thelma. So here it looks like there are 3, 6, 9, 12 possible different combinations. So look back and check. So check the tree diagram to make sure there are no possible first and second place outcomes you have overlooked. Doesn't look there. Double check the count for the winning pairs of runners. Like make sure you didn't double count, like there's none of the same. And looking at it, holistically and in the aggregate here, we can see there are 12 possible combinations. All right.